Welcome back, everybody. In this topic, we're going to have a look at configuring 802.1x authentication on the switch. So far, we've gone through the MAB authentication types, and we also seen what were the authorizations available to us. So we're not going to redo again the authorizations because, as we've said, it doesn't really matter if you authenticate a device using MAB or 802.1x, the same authorizations are available to us. So we're going to do just a basic 802.1x IP authentication. So from the configuration perspective on the switch side, it's pretty much the same requirements as in the MAB case, which means I need to enable AIA new model on the switch. So I'm able to do the integration with the radius server, which is going to be ISE in my case. I still again need to enable the authentication.1x. The new requirement would be that I need to globally enable .1x to make IP type of authentication functional, and that's the global command .1x system authentication control. And then at the port level, I also need to specify that the switch is a .1x authenticator, and also to basically enable authentication with the authentication port control auto command. We will go through some additional configuration options because we will need that based on the configuration that we're going to do. And then we'll go again, of course, to configure the ISE part of the network. Let's have a look at the diagram and let's see what I want to achieve. Basically, what I'm going to do is I'm going to use IPFast on testPCA. So IPFast on testPCA to authenticate. But the testPCA is connected to the IP phone, because the IP phone has a 2-switch port, and the IP phone is actually connected to switch 1. And switch 1 will be speaking radius with the ISE server. Now, previously what we've done, we used MAB for the port connected of R2. But in that case, we had basically a single MAC address on the port connected to the client. In this case, we'd have two different MAC addresses. One will be for the testPCA, and that would be in the data VLAN, and one for the IP phone, and that would be in the voice VLAN. In order to make this work, we need to configure something which is called the host mode. Let's go on the switch side, which is switch 1, and let's say show CTP neighbors. I see that the IP phone is connected on port FA105, and basically testPCA is connected behind the IP phone. If I go on interface FA105, I say authentication host mode. I see that I have different options: single host, multi-host, multi-domain, and multi-auth, with the default configuration being a single host. Whenever you want to see the defaults for the port, you can do a show run all. Let's say begin fast Ethernet 102, and you can see all the defaults for the port, and also what I'm interested into, the authentication type of defaults. And what I want to see is the authentication host mode, which says single host. So now basically the host mode governs what type of, how many devices you can have connected on the port, and how many devices do you want to authenticate on the port. And based on that, several policies may apply. The default host mode, as we said, is single host, which means that you can have a single MAC address authenticated and authorized on that port. So it means that if I have a connected client who authenticates, and then the switch will learn a new MAC address on that port, a violation will occur, and we're going to see in a minute what that exactly means. But again, it means that the switch will accept a single MAC address, and you'll authenticate a single MAC address. So we're going to use the single host mode whenever you have basically a singular client connected on that port. The second option would be to use the multi-domain mode, which this means that you can have a MAC address authenticated in the data domain and the MAC address authenticated in the voice domain. So you would want to use this functionality whenever you have the setup that we're going to test, which means that you have the device, the end user PC, which is connected behind the IP phone, and the IP phone is actually connected on the switch port. So this means that, for example, if the client, once the client and the IP phone are authenticated, if the switch learns a new MAC address inbound on that port, again, the violation will occur. So it's the same functionality. You have also something which is called multi-authentication, which means that you can have, again, a single MAC address in the voice domain, but you can have multiple MAC addresses in the data domain. Now, when you would want to use this is, for example, if you have some kind of virtualization on the end user PC, which means that the PC will basically initiate traffic with multiple MAC addresses. And at that moment, if you use multi-authentication, it means that the switch will enforce authentications for all the MAC addresses, which it sees inbound on the port, but it will allow multiple MAC addresses in the data domain. For the voice domain, the same restriction applies. The switch will allow a single MAC address, which means a single IP phone basically authenticated. And you also have something which is called multi-host. With multi-host, it means that the switch will enforce authentication for only the first MAC addresses that it sees inbound on the port. The following MAC addresses will be allowed, so traffic from the following MAC addresses will be allowed without being authenticated. You would want to use such a functionality, for example, when you have a switch and behind the switch, for example, you have a hub or another switch which doesn't have, for example, authentication enabled. And for example, not all the clients support authentication. And in that case, you would want to authenticate only the first MAC address, so the first client which connects to the network, and the following traffic will be allowed without the switch enforcing authentication. Another commonly used case would be, for example, on that port you have, for example, a Cisco lightweight access point connected, which runs in Flex Connect mode. And at that point, you would want to authenticate only the access point MAC address, but the Wi-Fi client traffic, which will be visible inbound on the port, you want not to authenticate that because basically the Wi-Fi clients are authenticated by the access points. You don't want to enforce a new authentication of the Wi-Fi clients at the wire level because anyways that is not going to work. Before we start the configuration, let's go and look. I want to show you something on the documentation. So let's go to products. And then we'll go to security and access control and policy. Then policy and access management, Cisco Secure Access Control System. We'll go to maintain and operate and user guides, and then to ACS 5.3. And you have in here something which is called authentication in ACS 5.3. This is a very good documentation of the different IP methods that you can use and are described pretty much in detail. So it goes through IP MD5, IP TLS, IP also to PIP. So this starts PIP version 0 and version 1, IP fast as well. So you can use this as a good reference point to learn more about the different IP methods. And also, if we go to back to products, security, and then to access control and policy, and then to Cisco Identity Services Engine, maintain and operate, and user guides, 1.1. You have here something which is called switch configuration required to support Cisco ISE functions. This is a good reference doc for most of the configurations which are required on the switch side, depending on what type of authentication you want to perform. For example, it says enable A functions, like enable A new model, and then configuration, configure the .1x, enable the .1x configuration. And then it says to enable the authorization network, which means to enforce the authorization received from the radius. So you have a good reference doc in here, which can help you to, configure the switch based on whatever actions you need to enforce in the network. Let's go back on the diagram. So as I said, we're going to use IPFast on test PCA, and the test PCA is connected to IP phone, which I would want to finally authenticate both the IP phone and the test PC. We're going to use IPFast, but in the end, it doesn't really matter which type of IP protocol you use, because on the authenticator side, which can be the switch or it can be the wireless LAN controller for wireless, the configuration is the same, because the authenticator is not aware and honestly doesn't care about whatever IP method the client wants to negotiate with the authentication server, which is Radius and in our case ISE. So the only changes based on whatever IP method you use, you would want to do that on the client side, because you need to configure the supplicant for the respective IP method. And you want to also basically configure the Radius server to support that IP negotiation. But other than that, the configuration, as I said, on the switch or the authorizations on the Radius server are the same. So let's go on the switch side. We have from the previous task already the integration between, so begin A, the integration between the switch and the Radius server. So I set a new model, and I've enabled integration with the Radius server, and then I've configured the authentication. Because I'm not going to do any type of authorization, I can basically remove this. It's not required to remove it. I just want to show that it's not required for whatever we need to demo in here. Also, I'm not going to be using the VSA functionality because I'm not using a DACL. So let's go ahead and remove this as well. Other than that, the configuration is pretty simple. So I want to enable authentication on the port, which is this one. So I have the IP phone connected in VLAN 47, and I have the PC connected in VLAN 27. So what I want to do is I say conft interface FA105. I would want to say authentication host mode. I want to have it as multi-domain, because I need a single MAC address in the voice VLAN and a single MAC address in the data VLAN. So multi-domain. Then I want to enable .1x as authenticator. And then I would want to say, let's say exit for the moment. I want to globally enable .1x, so .1x system authentication control. I am not yet going to enable the authentication on the port because I'm using test PCA to actually manage ISE. So let's for the moment go on ISE, and let's see what do I need to configure for the IPFast to function. So let's go to policy authentication first. Because I'm going to do a double authentication, let me reconnect to ISE GUI here real quick. HTTPS 172.16. All right, I'm already there. So let me authenticate again. Admin, default 1A. So because I'm going to do a double authentication, so I'm going to authenticate both the IP phone and the test PC. The IP phone doesn't have the 802.1x supplicant, so I'm going to do a MAB authentication for the IP phone, and I'm going to do a IPFast authentication for the test PCA. So I want to go to my authentication policies, policy authentication. I want to make sure that I properly match both authentications. So first I have a rule which was called MAB, which says that if the request is wire MAB, which it is for the IP phone, then the allow protocol is MAB, which should be good. I will go and verify that. And I'm using the internal user database. I want to modify this to the internal endpoint because I'm going to add the MAC address of the IP phone in the internal endpoint store. And I'm going to say, I'm going to save this. Let's go and verify that the allow protocol MAB allows for successful MAB authentication. So go to authentication and allow protocols, which is MAB. And I want to allow process host lookup. This was configured when I used MAB but with username-based password authentication, which I don't want to do that for the phone. I just want basic MAC address-based authentication in this moment. So I said save. So at this moment, when I receive the authentication request from the switch for the phone, I should match basically the first authentication policy, which is called MAB. Now I want to configure the second authentication policy. I want to make sure that this one matches on my EAP fast authentication for the test PC. So the condition says if wired 802.1x, which is the case because I'm going to do an EAP type of authentication for an Ethernet client. I'm using the default network protocols. I want to verify that EAP fast is allowed in there. And then I say use internal users, which is good because I'm going to use EAP fast with EAP MS-CHAP as the inner method. Let me go to policy results and also configure a specific authentication profile for EAP fast. I say add EAP fast because I want to see in the logs that I match the properly configured authentication policy. So I say EAP fast, and I'm going to basically allow just EAP fast in this. So I'm going to disable all the other options. This is of course optional. I'm just using this to show you that you can be specific and to make sure that I match the required authentication policy. When I use EAP fast, so just EAP fast is enabled, I want to do, so I can choose to use packs or don't use packs. I want to use packs because I want to have the inbound pack file provisioning, so the automatic inbound pack file provisioning. And I have two options in here. One says allow anonymous inbound pack provisioning, which requires me to have enabled both EAP-GTC and EAP-MS-CHAP as the inner methods. And one is allow authenticated inbound pack provisioning. The difference between anonymous and authenticated is that with anonymous, when the radio server, which is ISE, will push and generate a pack file for the client will not try to authenticate the server, which in my case I want to do that. The authenticated option would be that when the ISE server would try and push the pack file to the client will first try and authenticate the server. And that will be done based on a certificate on the server side, which of course means that the client needs to trust the CA that issued the certificate for the ISE server. So in my case, I'm just going to say allow anonymous inbound pack file provisioning, which was the first method. And I want to say allow EAP-MS-CHAP, as I said, allow EAP-GTC, because this is required for the pack file provisioning, because basically in phase 0 of EAP fast, when the ISE server pushes the pack file, it uses a combination of EAP-MS-CHAP and EAP-GTC to successfully allocate the client a pack file. So let's go and say submit. Now let's go on the authentication policy for the test PCA. And I want to modify the .1x rule to use my configured set of protocols, which is EAP fast. And I'm going to authenticate that against the internal user database. So as I said, in EAP fast phase 3, which basically authenticates the client, I will use a username-based password authentication. So at this point, as we've seen, I have the switch basically integrated with ISE. I've configured the two authentication policies. Now what I want to do is I want to add the MAC address of the IP phone in the internal endpoint store, and I want to configure a username password which will be used by the test PC to authenticate through EAP-MS-CHAP. So let's go on the switch, which is this one, and let's say show MAC address table, dynamic interface FA105. And the MAC address of the IP phone should be in VLAN 47. So this is the MAC address of the IP phone. Now we'll see what the problem is, because if we look at the show MAC address table output, we see that the MAC address of the IP phone shows up in both the data VLAN and in the voice VLAN. For the moment, let's leave it as is. Let's just go into ISE and add the MAC address of the IP phone in the internal endpoint store. So I'm going to go to ISE, and I'm going to say administration, and I'm going to say identities, endpoints, and then I'm going to say add, and I'm going to add the MAC address of the IP phone, which was 0003. So I'm going to say 0003, and then 6B3C35F0. So that's 6B3CF530. Let me check that again. So that was 6B3C F5F0. So 6B3C35F0, which is good. I'm going to say submit. And I'm also going to add a user which will be used by the PC to authenticate via eepfast. So I say add, and the name would be, let's say, eepfast. The password will be eepfast123 and eepfast123. And I'm going to say OK, submit. Now what I need to do further is I want to go to the authorization policies, and I want to make sure that both the IP phone and the test PC will match an authorization policy. The first thing we need to remember is that when you do the authorization for the IP phone, which is for the voice domain, ISE needs to push the voice domain authorization setting. Otherwise, the switch will not let the phone join the voice domain. So I still need to do some kind of authorization just for the voice domain VLAN for the IP phone, but for the test PC, I'm just going to say an access accept, so I'm not going to send any type of authorization attributes. So let's go on policy, and I'm going to add 2 authorization profiles. So I say results, and then authorizations, authorization profiles. I'm going to say add, and I'm going to say IP phone, and I'm going to say that I allow voice domain permission. So that's the only thing I need to do, and I'm going to say submit. I have a default Cisco IP phones profile, which I could have used. The difference being that this one also enforces a DACL, except the voice domain permission. I'm just going to use mine because I don't want to enforce any type of DACLs. And now I want to create another authorization profile for the test PC, which I say add, and I'm going to name this eepfast, and I'm going to say just access accept. So I don't want to enforce any kind of attributes. I just say submit. Then I go to my policy, so I say policy authorization, and I'm going to add these new policies. So I have one from the previous task which says map wired. If wired map, then map wired profile. Basically, my IP phone, based on this config, will match this authorization policy. So I just want, for example, to change this one and apply the newly configured authorization profile. So I'm going to say edit, and I'm going to give it a name IP phone, for example. I leave the condition as wire map, but I'm just going to apply the IP phone authorization profile, which allows the IP phone to join the voice domain. So I'm going to say IP phone, and done. And I also want to say edit and insert a new rule below, which this would be used by the client, by the test PC. So I say test PC. Condition would be I'm using a wired.1x, type of authentication, compound, wired.1x, and I want to say that the authorization profile would be one which was called IPFast, which basically just sends an access accept message back to the switch. So I'm going to say save. At the same time, I need to go on the switch and re-enable the authorization network, because otherwise the voice VLAN authorization received from ISE will not be enforced by the switch. So I want to say AA authorization network default group ISE radius. So at this moment, what I need to do is I want to enable the authentication on the port facing the IP phone and the PC, and I want then to go on the test PC and enable the supplicant. Because I'm using the IPFast protocol, which is not supported by the Windows native supplicant, I will have to go and configure the AnyConnect supplicant for that. So let's see what configurations are done on the switch port FA105. So I want to go into interface FA105. I said that the host mode is multi-domain, which is good. I enabled the switch as the authenticator, which is good. Then I want to say MAB, but before I do that, there is something which is called authentication order, which by default is .1x first and MAB then. If you think logically, basically, first thing that will get connected to the switch port is the IP phone. So because the IP phone will do MAB type authentication, you would want to have MAB first and .1x second. So you don't want the IP phone to wait like 90 seconds before the switch fails the .1x negotiation with the IP phone and then fail over to MAB. Because if you do .1x authentication first, basically the switch will send IP over LAN queries to the IP phone asking for IP negotiation. And it will retry that 3 times, which means pretty much like based on the default settings like 90 seconds, it will still it will continue asking the IP phone for .1x negotiation, which again it will fail because the IP phone doesn't have the supplicant, doesn't support the .1x supplicant. So that's why I want to have MAB first and then .1x. So I'm going to say authentication order MAB.1x, which by default is the other way around. And then I'm going to enable MAB on the port. And I'm going to say also authentication port control auto. Meanwhile, let's go on the test PC side and let's configure the supplicant, which is the AnyConnect. It says service unavailable because I want to enable the service. So I want to say services.msc to basically enable the NAM agent module. Before we do that, I want to show you something for the native supplicant. If you go in the configuration of the network interface card and say properties, if you want to use the native Windows supplicant to do the authentication to the 802.1x, which supports only PIP and IPTLS, in order for the authentication tab to be available to you, you need to make sure that there are 2 services which are started on the Windows side. So you need to make sure that when you go to services.msc, look for the services which are called Windows. It's named, let's go here. So it's VLAN auto config for the wireless. So if the client has a wireless network interface card and you want .1x authentication on that, you want to make sure that the VLAN auto config is started. And for the wired part, you want to make sure that the wired auto config is started. For AnyConnect, I just need to enable the service which is called Cisco AnyConnect Network Access Manager, which is disabled. Let's say properties, first enable, automatic, apply, and then start the service. So now I will go on the AnyConnect client. which is this one, and I'm going to say advanced networks, and I'm going to add a new profile, which I say it's of type wired. I give it a name, let's say IPFast, and I'm going to use that one next authentication, IPFast with type of password, which means the inner method is IPMSCHAP v2, and I'm going to say OK. And then I'm going to bind this method as the authentication on the port. Let's go on the switch side and say show authentication sessions. So I see that the voice and data VLAN were, so I'm using port 5. So on port 5, I see that the voice VLAN with the IP phone was successfully authenticated, but the data VLAN failed. Let's go back on the supplicant. So I got the prompt to configure the username and password, which was IPFast, and then IPFast123, and I'm going to say OK. Now at this moment, you'll see, if we go on the switch side, you'll see a lot of messages between the client and the radio server, which is ISE, because basically they need to negotiate the three phases. So first, phase 0 will happen, which means that the ISE server will need to generate the pack file and issue that pack file to the client. Then phase 1 needs to be negotiated, which means the secure tunnel will be negotiated between the client and the radio server. And finally, within the secure tunnel of phase 1, the client authentication will be performed, which in my case, I'm using IPMSCHAP v2. So you might want to give it a few minutes, or maybe like 1 minute, 2 minutes before it finally succeeds to do the authentication. So let's go on the switch side. Let's say show authentication session. Let's see if it finished. So it still says failed. Let's go on the client side. Now I got a message that it says connected to IPFast. So this means that it should have succeeded. Let's go back in here and say show authentication sessions. Let's say interface FA105. So I see that both the data domain of FA105, which is this one, and the voice domain, I have an authorization success message. Let's see the details of the authorization. So first is let's first disable the logging. Let's say no EPM logging for the moment. And let's do again the command. So first I look at the data domain, which says authorization success, and authorization was done by the authentication server. I have, as we've configured, I have no VLAN assigned and no decals assigned, but it says that it tried first map based on the authentication order, which failed, and then it tried .1x, which succeeded. And I also have the voice domain. So the voice domain, it says status authorization success, and authorization was done by the authentication server. And again, I have no type of decal assigned, and it says here that it was successful through map because map was the first method tried by the switch. So it didn't get to run .1x because it was not required, because map was successful. So now if I see show MAC address table, interface FA105, I should see both MAC addresses as static, which I do. So this, again, this confirms that basically both MAC addresses were successfully authenticated and authorized by the switch. Now, from the configuration perspective, if I do a show run interface FA105, so I managed to change the order, and I said the authentication host mode is multi-domain. We said that we can also change the violation policy. So I say authentication violation, question mark. And this is, if we look at the options in here, these are pretty much the same options as they were with if you did port security on this port. Because basically what .1x or MAB authentication does, when the switch authenticates the clients on that port, on those ports, when it converts the MAC addresses from dynamic to static, it basically performs a type of port security. So when you do the authentication on the port, you no longer need to do port security. That functionality is built in there. It's built in the MAB or in the .1x authentication. So we have here something which is non-protect. So the violation would mean that in this moment, because the host node runs in multi-domain, if the switch will receive a new frame with a new MAC address on this port, that will not be allowed because the multi-domain allows only one MAC address in the data domain and one MAC address in the voice domain. Then the violation will happen, which if it's protect configured, then it will mean that the switch will drop all traffic inbound from that client. If I configure it to replace, to restrict, let's say, restrict is the same functionality as protect, only that the switch will additionally log a message and send an SNMP trap. The default configuration is the shutdown option, which means that the port will be put into error disabled state, which is a kind of a logical shutdown, is not a physical shutdown. And the last option would be replace, which this is not an option for port security. So protect, restrict, and shutdown are also available if you do basic port security on the port. Replace functionality is supposed to work in this way. So, and this might apply in this case when you have the multi-domain configuration enabled. Because let's look back at the diagram. Let's open the diagram in here. Let me open a new one. What happens is that when the IP phone connects to the port, it basically sends untagged packets because the IP phone is not aware yet of the voice VLAN. So because it does that, it means that the switch will learn the MAC address of the IP phone in the data VLAN. Once the IP phone boots up and gets authenticated and authorized, and it gets the authorization from the ISE server, and it's allowed to join the voice domain, then what happens is that the IP phone will learn through CDP the voice domain. So the switch advertises the voice domain through CDP for the IP phone, and once the authorization is received from ISE, which allows access to the voice domain, so once this happens, the voice domain, then only at this point the phone will start sending tagged frames, tagged packets. So tagged packets, and this time in the voice VLAN. So at this moment, what ends up happening is that the switch will have the MAC address of the IP phone learn in both the data domain and the voice domain. Of course, the MAC address from the data domain will expire after like 5 minutes, which is the default MAC address timeout. But the problem would be that now if I come and connect the test PC, so now let's say that this PC comes and is connected behind the IP phone, because test PC will send untagged frames, switch 1 will learn that MAC address is being in the data VLAN. But now at this point, because I'm running in multi-domain mode and the switch allows a single MAC address per domain, because switch will see a new MAC address on the data domain, it will force the violation, which by default being shut down, it means it will put the port into error disabled. So if you don't want that to happen, then what you can do, you can go on the switch and you can say authentication violation replace. Because what replace does is that based on my scenario, when the test PCA will send traffic and switch 1 will basically receive a new frame with a new MAC address in the data domain, if the replace violation actually is configured, switch 1 will remove the old MAC address from the data domain, and it will allow test PCA to be properly authenticated on the network. This, I mean, in our case, the problem didn't happen because it really depends on the order of sequence. If, for example, both the IP phone and the test PC are connected to the network, or only first if the IP phone is connected, and then, for example, the MAC address expires from the data domain, and then when the test PC joins the network, because the switch has no MAC addresses in the data domain, it will successfully allow the test PC to authenticate. So it really matters. It's not always the case that you'll get into the violation, which is the default shutdown. But when you have the multi-domain enabled, it's wise to say that the authentication violation should be replaced. Let's quickly go into the ISE logs and see the results. So I want to go to operations and authentications. And basically, I should see, let's look for the MAC address. So I see here that this one, the IP phone authorization profile happened. So let's click on this one to see the IP phone authentication. So it says authentication succeeded, and then it says that it performed the MAB through lookup. I matched the allowed protocol MAB, which means I matched the authentication policy of MAB. And then the authorization profile was IP phone. So this confirms that I matched the properly configured authorization policy. And now if we go to the test PC authentication, I first see that I see an initial authentication log, which this is for phase 0. And this was used to just do pack provisioning for the client. And I see that the inner method was IP mschap. So this is basically the result of phase 0 being successful. But once phase 0 is successful, it doesn't mean that the client gets access to the network. The client needs to go further to phase 1 and phase 2, and only afterwards, if it gets successfully authenticated, it will be allowed access to the network. So let's go further to the ISE logs, and let's look at the final authentication log, which this would be for IP fast phase 3. And I see that authentication succeeded. I used the same inner method as IP mschap. The allow protocol was IP fast, so I properly matched the authentication policy. And the authorization profile was IP fast, so I properly matched the authorization policy again.